All right. It's time to make a video here today. We're going to review all of our motion graphs. We're going to go over the misconceptions. We're going to have simple graphs, and we're going to end up with complicated graphs. And hopefully this will be a video that we can refer back to when we are working on our project at home. So let's start off first by talking about probably the most important thing that we are going to do when looking at graphs. And the very first thing we're going to do when we look at any graph is we're going to see what kind of graph is this. So I would recommend every single time that you look at a graph, you look at the X and the Y axis and you realize that this graph in particular happens to be a distance time graph, and that's going to make a huge difference as we move on into what's going on the graph. Now, on a distance time graph, if you happen to see a straight line anywhere on the distance time graph, we need to think about what's going on here. So let's just say there is a track, and it's a 100-foot track, and when we start monitoring a car that's on this track, it's stopped at the 60-foot point of the track. And so we might start our graph here, and 1 second goes by and the car is still sitting in the same spot. 2 seconds goes by, it's still sitting on that 60-foot mark. 3 seconds go by, 4 and 5. And what you're noticing is the car is sitting at the same spot. And that's very important to notice, because if the car is sitting at the same spot, it is not in motion. When we have a straight line like this, well, I should say a horizontal line, because a vertical line would be very different. But when we have a straight line like this, a horizontal line on a distance time graph, you know that the object, whatever that object is not moving. So in a distance time graph, this actually means at rest. This means at rest. The object is not moving. As time ticks by, the object stays in the exact same spot. It's not moving. Therefore, it is at rest. Swing my microphone around this way. See how that sounds later on. And presto changeo, just like that, probably in the video. I'm going to go back and watch that and see how quickly that clicks over since I paused it. We have a new graph. Now, I'm going to draw something that looks very similar to our last graph. And you might be saying, hey, Mr. Bullens, I hope you're okay today there at school, because that looks like the exact same graph as last time. You have to be very careful. Remember, anytime we're working with graphs, the very first thing we're going to do, we're going to look at what type of graph are we looking at. And this time around, we're looking at speed time graphs. So let's go back and think about the speed time graph. So as we are looking at an object, we'll just say it's a car this time. As 1 second goes by, the car, if this is speed, maybe it's miles per hour, the car's going 60 miles per hour. We clock it again another second later, it's going 60 miles an hour. And as you notice on this graph, every time we check the speed of this car, it is going 60 miles an hour. Now, it is very tempting when you see this graph to say that this is an object at rest. However, is it possible for an object to be at rest if it is going 60 miles per hour? The answer to that is no. So we have now covered probably the first misconception that we might have. And we can minimize our chances of making that common misconception if we think quickly at the beginning, okay, what type of graph is this? If we do that on all of the graphs, the odds of us making this misconception fall greatly. And we just work our way and we think about what's going on in the graph. Now, so we know that we have two different types of graphs. We have a distance time graph, and we have speed time graph. And these graphs may look exactly the same, but we know that they are actually completely different. One of them is not moving. One of them is moving. And all you have to do is, again, you pay attention to what's going on right here on your y-axis. So that is our first misconception that people make very often. I'm also going to kind of go back and take a look at this. And it doesn't matter which graph. It could be a distance time or a speed time graph. Many times people will see this, and I'm going to do it in red so it'll kind of make you think, stop. They see this, and they think, oh, whatever that object is, it's driving on a flat road. That's not necessarily true. I could maintain a certain speed if I was going down a hill. I could maintain a certain speed if I was going up a hill, and I can maintain the same speed if I'm going on a flat surface. The ups and downs on these graphs do not represent hills and like flat parts of roads. They are representing the motion of an object. Whether it is moving or not moving, whether it's accelerating or decelerating, those types of things, but it's not going to tell you going up a hill, down a hill, or anything like that. So we've covered the first one, so we're going to come back here in just a second and cover our next one that people tend to get mixed up very often. And we are back pretty quickly there. And again, I think if you're very careful and you pay attention to what I said, we're going to pay attention this time very quickly to what type of graph this is. And we have changed back to a distance time graph. And often on a distance time graph, you're going to see this type of motion. And so if we were to look at an object, and we're just going to call this, maybe this is distance in feet, and feet per second. So when 1 second goes by, you'll kind of, I'm going to kind of do it like you see me go to 1 second, and I go up to 10. So my object went 10 after 1 second. So when 2 seconds go by, my object had actually gone 20 feet. After 3 seconds had gone by, my object had gone 30 feet. After 4 seconds have gone by, my object has gone 40 feet. And after 5 seconds has gone by, my object has gone 50 feet. Again, my time is down here. My distance is going up this way. So time's going this way, distance is going this way. And you'll notice that I'll have something that looks similar to this. If we pay attention to what's going on here, we're going to realize something. And if we need to do the math, we can actually do the math, because remember, distance divided by time gives us speed. So if I say 10 divided by 1, I get 10. 20 divided by 2, 10. 30 divided by 3 is 10. 40 divided by 4 is 10. And 50 divided by 5 is 10. Every single time I measure this object, it's going 10 feet per second. So the speed is staying the same. As time goes by, speed stays the same. And we have a very technical term for that in science. We call this constant speed. Constant speed. Now, again, we're going to cover some of the misconceptions on this. So I'm going to take away some of these marks that we just did here on our constant speed graph. Whoops, I need to put that one back. Boom. Now, what we don't want to say, okay, we're not going to say, this is not a graph of a car going up a hill. This is not. Should do that in a different. Not a hill. Okay? We don't want to get that part confused. That's the easy one to not get it confused with, because I'm flat out telling you it's not a hill. It is not a hill. All right, I think I'm in the right spot. I did just have Mr. Reynolds come in and do a quick evaluation on me. So if I'm talking about the wrong thing, I'm sorry. It really kind of paused my thinking there. So all of a sudden, we've eliminated everything. We just talked about how this is not a hill, so we won't talk about that again. But before I start looking at this graph in particular, I need to, again, what kind of graph is this? This time it is not a distance time graph. It's a speed time graph. And if I look at this speed time graph and I start analyzing what's going on in the speed time graph, when I checked my speed at 1 second, I'm glad I did that. Before I did that, I realized that this object was going 10 miles an hour. When I checked it at 2 seconds, it was going 20. At 3 seconds, it's going 30. At 4 seconds, it's going 40. At 5 seconds, it's going 50. 6 looks like it's going to be 60, and then 70, and then so forth. If I take a look at this, I have to realize that this is actually very different than the last graph that I had. The last graph that I had, the car or whatever it was happened to be going the same speed every time I checked it. This time it is not, because look, it's going 10, then 20, then 30, then 40, then 50. Can you see how it's going 10, then 20, then 30, then 40, then 50, then 60, then 70, then 80? This car is actually speeding up. So what we would call this graph is acceleration. So again, we have to be very careful. We have two graphs. On the distance time graph, this is constant speed. But on the speed time graph, this is acceleration. Really and truly, if you follow the rule of checking your graph before you start working on it, I think you will be fine in not confusing speed graphs with distance time graphs, because speed and time graphs are very different than distance time graphs. And boom, just like that, it goes to a completely different graph. Now, before I get into this, and I do what I'm going to do every time, which is find out what kind of graph it is, I do want to draw this one over here really quickly, just kind of out of here. So I have this speed time graph that we just drew, and we said it was accelerating. Okay? Remember, the first thing we're going to do is check our graphs. This happens to be a distance time graph, and this is the only time that we're going to see something that doesn't have a straight line. I might have a line that curves this way. I could have a line that curves down. In my lines that are curving up, on a distance time graph, if the line curves, it is an acceleration. If it curves downwards, then we are slowing down. And we're going to add that vocabulary word this week. We're decelerating. So if you see a curved line, if the line is curving up, we're accelerating. If the line is curving down, we are decelerating. Okay, and it's very different than this one up here. But again, it's easy to get confused because there's two accelerations. So I understand that, but again, if we pay attention, distance time graphs, if we have a curve, it is acceleration. I'm looking, I don't know if you can see the time that I can see, but I'm looking at the time down there, and I really don't have enough time to keep diving into the graphs that we're doing. So it looks like we're going to have two 15-minute videos today. I wish I could get all of the time on one, but with the free version of Screencast-O-Matic, you only get 15 minutes, but that's pretty awesome. You only get 5 with some of the other ones, so I can get a lot of stuff done. Anyway, that's the first portion, so we'll label this Motion Graphs video number 1, and as soon as I get off of here and get this uploaded, I'll start recording Motion Graphs video number 2. I'll get all those uploaded and posted. Again, don't forget to smash that like button and subscribe, and I will see you in just a few moments for our Motion Graphs video number 2.